Gasland, Halliburton, Marcellus Shale, hydraulic fracturing. These are just some of the key words surrounding the controversy with hydraulic fracturing. But what is hydraulic fracturing? According to the EPA, hydraulic fracturing is a well stimulation process used to maximize the extraction of underground resources, oil, natural gas, and geothermal energy. The hydraulic fracturing process includes the acquisition of source water, well construction, well stimulation, and waste disposal. Hydraulic fracturing involves the pressurized injection of fluids commonly made up of water and chemicals additives into a geological formation. The pressure exceeds the rock strength and the fluid opens or enlarges fractures in the rock. As the formation is fractured, a popping agent, such as sand or ceramic beads, is pumped into the fractures to keep them from closing as the pumping pressure is released. The fracking fluids, water, and chemical additives are then returned back to the surface. Natural gas will flow from pores and fractures in the rock into the well for subsequent extraction. Wells used for hydraulic fracturing are drilled vertically and horizontally or directionally. Wells may exceed to depths greater than 8,000 feet or less than 1,000 feet, and horizontal sections of a well may extend several thousands of feet away from the production pad on the surface. Where does the controversy start? It begins with the hydraulic fracturing process. Here are some of the facts stated by the EPA. These operations can result in a number of potential impacts to the environment, including stress on surface water and groundwater supplies from the withdrawal of large volumes of water used in drilling and hydraulic fracturing, contamination of underground sources of drinking water and surface waters resulting from spills, faulty well constructions, or by other means, adverse impacts from discharges into surface waters or from disposals into underground injection wells, and air pollution resulting from the release of volatile organic compounds, hazardous air pollutants, and greenhouse gases. Not only do we have these problems, but there are subtle and unknown problems with hydraulic fracturing. One of the big problems with hydraulic fracturing are the chemicals involved in the process. Many natural gas companies have disclosed these chemicals, however, they are not environmentally friendly in the least bit. For example, ethylene glycol, or antifreeze, is used as a winterizing agent in the chemical process. Here is where another problem arises: identifying these chemicals. Many of these chemicals have multiple names. Again, using ethylene glycol, or antifreeze, is also known by the name of ethylene alcohol, glycol, glycol alcohol, monoethylene glycol, ramp, tescol, 1,2-dioxytrithane. All these chemicals listed have alternate names that hide the true nature of the chemical from the general public. What average person is going to take the time to go through every chemical and find the countless of alternate names associated with each? Now keep in mind, while these are potential problems, it does not mean that the probability of this happening is very high. Currently, the EPA is doing a study on the hydraulic fracturing process in order for it to follow the Clean Air and Clean Water Act. But it is only a study, and there are already 33,277 registered wells operating in the United States, some in New York and Pennsylvania, which is receiving the most media hype in the past year. The Marcellus Shale, which runs from New York and extends in the Appalachian Basin, the amount of natural gas the shale contains is 14,000 kilometers raised to the third. The potential to tap into this vast quantity of natural gas is huge. However, most of New York's natural aquifers and drinking waters lies with the Marcellus Shale. Now you can see the problem New York faces. If the aquifers and the environment would potentially be contaminated from hydraulic fracturing, it could spell devastation for the entire state's drinking water supply. What does this mean for the future? Because there are so many unknowns in this relatively new industry and so many unknown externalities, my suggestion is for the natural gas industry to be regulated by the U.S. government. Currently, many of the practices and other technologies used in hydraulic fracturing are unknown and underregulated. As Rachel Carson said, over the past decade, these problems have cast long shadows, but we have been slow to recognize them. Most of those best fitted to develop natural controls and assist in putting them into effect have been busy labor, and more exciting vineyards of chemical control. We need to regulate the industry because we do not want these underlying problems to develop and destroy our potential future. Natural gas is a cleaner source of energy. It burns 15% less carbon than coal and not as many harmful greenhouse gases. This is a resource we should not easily give up, but we should make it safe. Many people question, why are we drilling for natural gas in the first place when we are trying to switch to a more sustainable planet? However, my answer is time. It's going to take time in order for us to implement and utilize green energy. Our whole infrastructure is based on carbon products. Our faulty electrical grid derives most of its energy from coal. We need to make small steps in order to work to the idea of a sustainable planet. If we could replace coal with natural gas, that would be the correct step in the right direction. For coal and all the things that come with it, with mining, mountaintop removal, burning, and waste disposal, it is far worse than natural gas could ever produce. Natural gas, it's a cleaner, more abundant resource. We can utilize it to help clean our electrical grid and reduce our dependence on foreign oil. It can generate countless of jobs across America and boost our economy. It is a resource we should not let go easily, but it must be managed and regulated accordingly. To leave you with some hope of the future, here is a quote from Leopold. The outstanding scientific discovery of the 20th century is not television or radio, but rather the complexity of the land organism. Only those who know the most about it can appreciate how little is known about it.